So hello my dear friends, I hope all of you are doing fine. So I welcome you all to my 14th video lesson of class 9 physical sciences. Right students? So in our today's class, what we will be learning is that I'm showing you with the help of this picture. So now let's look at this picture. So students, please take a close look at this picture for 10 seconds. Then I will ask you what you have seen in this picture. Okay students? Right. So students, in this picture, we can see animals that can fly. We can see animals that walk and run. We see animals that can swim. We see animals that can crawl, right? So in short, we can say that this slide represents the different type of motions in animal, right? Different type of motion in animal. So the first question arises, why does the animals need to show motion, right? Why does the animals need to show motion? The answer can be varied, like animals have to find their own food, their own shelter. For that, they have to migrate they have to go from one place to another. For that, they require motion, right? So today, our class is dedicated to this topic called motion. We will be studying about something related to motion, right? We will be describing the motion, right? We will be describing the motion, right? Students, just take a look at this picture. What you can see in this picture, students? Yes? Okay. So here in this picture, you will find two persons, person A and person B, right? Let's suppose the name of this person is A and the name of this person is B, right? So these two persons A and B are sitting in front of each other, right? And they are sitting in a train, right? So have you ever come across some situation like this, that you and your friends are traveling in a train or in a bus? So you are sitting face to face with each other, like also in the car, like you and your friends are sitting next to each other, and you can very easily talk to them, isn't it? You can talk to them, you can chat with them, you can take their phones, they can take your phone, isn't it? So this type of things happen inside a car or inside a bus, right? So but is it possible that a person standing outside the train here, can this person chat with this person who is standing outside the train? Yes students, tell me, is it possible? Yes or no? So no, it is not possible, right? Because there is something, whenever we are describing some type of motion, so what is happening, we are describing with some type of reference, right? So this person who is outside the train will move quickly past this person, isn't it? So they won't be able to chat with this person, right? So now let's see. Now we will study about point of reference, right? So an object may appear to be moving for one person and stationary for some other person, right? So an object might be appearing to move for one person and it might appear to be stationary for some other person, right? So for the passengers moving in a bus, the roadside trees appear to be moving backward. You can also see that whenever you are coming to school by the bus, you might feel that someone who is standing on the road, he is moving backwards. But actually, he is not moving backwards. You are moving forwards. Right? So a person who is standing on the roadside perceives the bus along the with the passenger as moving, right? However, the passenger who is inside the bus sees his fellow passenger at rest, right? So this person is seeing this person at rest, right? We describe the location of an object by specifying a reference point, right? Whenever we need to specify the location of an object, we need to describe a reference point, right? So to describe the position of an object, we need to define a reference point, and what we call that reference point, we call that reference point as origin, right? Yes students, we call that reference point as origin, right? So in this module, what we have learned that the motion can be appearing like stationary. Even if when we are in motion, we might appear stationary to someone, but at the same time, we may appear to be moving to some other person. Like, for example, here we have taken an example of the passengers traveling inside a bus, right? So in that case, what is happening? The persons who are inside the bus, they are at rest with reference to each other, right? But a person who is standing outside the bus or outside the train, what he sees that the train is moving with all those passengers, right? So whenever we want to describe any type of motion, so first of all we need to define the point of reference, right? So the point of reference is also called as the origin, right students? The point of reference is called as origin. Yes, very good students. So now let's proceed. Now there is a quiz for you students. So the first question of the quiz is, what is the point of origin? Yes students, who will answer this question? Right. So to describe any motion, we need to first set out a point of reference, and that point of reference is called as what? That point of reference is called as origin. Right. Now students, look at the second question. So the second question is says that the description of motion can change with respect to the point of origin. So is this statement true or false? The question states that the description of motion can change with the respect to the point of origin. So this statement is true or false. What do you think students? Yes. So this statement is a true statement, right? Because we know that the description of the motion can change with respect to the point of origin. Right, students? Now let's proceed ahead. So students, what you can see in this picture? Yes, right. Some a sort of scale is there and a car is moving, right? So we say that it is for the car is following a linear motion, right? It is in the one single line, so it is called as the linear motion. Okay, so now these are some examples of the rectilinear motion. Okay, so suppose that an apple is falling from the tree, so that is an example of the linear motion or rectilinear motion, right? A pushing of the box on the surface of the table, that is also doing what? That is also linear motion. A march passed by a band in a straight line, that is also linear motion. Understood students? So now let's see about this thing called distance and the displacement, right? So you see, let's mark this point as A and let's mark this point as B. Okay, so to reach B from A, we can either take this path, right? We can take this path, a long path, and reach B. So it can be the distance, but the displacement is always the shortest path, right? The shortest path between A and B is the displacement. Okay, students? Right. So now let's look at the difference between the distance and the displacement. So students, distance is the length of the path traveled by a body while moving from its initial position to the final position. Okay students? So distance is the length of the path traveled by the body while moving from the initial position to the final position. Okay students? But displacement is the shortest distance between the initial position and the final position of the body. Okay students? Right. So distance is a scalar quantity. Distance is having only magnitude, but it is not having any type of directions. Okay. But displacement, it is a vector quantity. It is having both magnitude and the direction. Okay. Right. So distance measured is always positive. Understood students? The distance is always positive, but the same cannot be said for the displacement. Why? Displacement can be either positive, it can be negative. It all depends upon the point of the reference. Okay? The total distance covered is equal to the algebraic sum of all the distance traveled by the different directions. Okay, students? So if we try to find the total distance, suppose that there is someone who has traveled 5 kilometers to north, then he has traveled 5 kilometers to east, right? Then he has traveled 5 kilometers to south, right? And then he has traveled 5 kilometers to west. So now what will be his distance? His distance will be 5 plus 5 equals to 10 plus 5 is 15 and then again 5 it will be 20. So distance will be 20 kilometers, right? But in the case of displacement, the person has started from A and had reached B. So A and B are at the same point. So that person will not have any sort of displacement. Understood, students? Okay. So displacement is the vector sum of the individual displacement in the direction. Okay. So what is the unit of distance? The unit of distance is meter. Understood? And the unit of displacement is also meter. Okay. So now let's move ahead. So students, how we can differentiate between the distance and the displacement? Okay, so to differentiate between distance and the displacement, we can say that distance is a scalar quantity. It is having only magnitude but no direction. But displacement is a vector quantity. It is having both magnitude and the direction, right? So distance, when we are talking about the distance, it is the sum of the arithmetic sum of the all the distances followed by a body, right? All the distances covered by a body. But the displacement is equal to the vector sum of the components, right? After that, we can say that distance can never be zero or negative, right? We can say that distance can never be negative, but same cannot be said for the displacement. Displacement can be either positive, it can be either negative, or even it can be zero. It all depends upon what? It depends upon the point of origin. Okay, students? Right. So now let's move ahead. So students, look at this picture very carefully. What you can observe from this picture, students? Okay, so from this picture, you can see that this car is covering equal distance in equal time. Okay, so this car is covering 4 meters in 2 seconds. Okay, then again next 4 meters in 2 seconds, then again 4 meters in 2 seconds, and again 4 meters in 2 seconds. So the total distance traveled by this car is 16 meters and the total time taken is 8 seconds. Okay, so this car is showing one type of motion. So now let's see again this picture. Okay, students, see this car has taken 2 seconds to travel 1 meter, but now it has taken 2 seconds to travel 9 meters, right? And now it has taken 2 seconds to travel 15 meters, right? So this car is showing this type of motion. So is both the motions shown in these two slides the same or are they different, students? Yes, students? Right. So they are very different motions. So first, the example that we saw in the previous slide, it was the example of uniform motion, and this picture here, it is non-uniform motion. Okay, it is non-uniform motion. Right. So now let's look what is the difference between the uniform and the non-uniform motion. Okay. So by uniform motion, we mean that the uniform motion implies that the body is moving along a straight line. Okay. The body is moving along a straight line with a steady speed, right? It is moving along with a straight line at a steady speed. But the non-uniform motion says that the movement of the object in a straight line is with the variable speed. Okay, students? Now, In the case of uniform motion, the body covers equal distance in equal time interval. Okay. But in the case of non-uniform motion, the body covers unequal distance in the equal time interval. Okay. Right. So in uniform motion is similar to the actual speed of the object, right? But the non-uniform motion is different from the actual speed of the object. Okay. So when we will look at the distance time graph in our next class, we will find that the distance time graph for the uniform motion is a straight line, but the distance time graph for the non-uniform motion is not a straight line. So for the distance time graph d and t, distance time graph for the uniform motion, it will be a straight line, but the distance time graph for the non-uniform motion, it will be like this. Okay, students? So, in the case of uniform motion, there will be no acceleration, or we can say there will be zero acceleration. Okay, but in the case of non-uniform motion, there will be non-zero acceleration. Understood, students? Okay. So now students, let's see what is average speed. Okay. So students, average speed is defined as total distance covered divided by total time elapsed. Okay. When we find the ratio of total distance covered by total time elapsed, it gives us what? It gives us average speed. Okay. So average speed can be defined as total distance traveled for the object in question divided by the total time elapsed. Okay, so that will be what? That will be the average speed of that object. Okay, students. So now let's move ahead. So there is a quiz for you, and in this you need to differentiate between the uniform and the non-uniform motion. So first of all, in the case of uniform motion, we can say that the body covers equal distance in equal period of time, right? So that is uniform motion. In the case of non-uniform motion, we say that the body is covering unequal distance in the equal period of time. Another difference can be what? Another difference can be that in the case of uniform motion, there is no acceleration, or we can say there is zero acceleration. But in the case of non-uniform motion, there is non-zero acceleration, or we can say there is acceleration happening there. Okay, students? Right. So when we will look at the distance time graph for the uniform motion, it will be a straight line, but the distance time graph for the non-uniform motion, it will be what? It will be like this. It will not be a straight line. So these are some of the differences between the uniform and the non-uniform motion. Okay, students? So now let's proceed ahead. So in our today's class, what we have learned to describe motions, okay, types of motions and motion along the straight line. Okay, students. So now, just now we have differentiated between the uniform and the non-uniform motion. So once again, so uniform motion occurs when an object covers equal distance in equal period of time. Then we say that that type of motion is uniform motion. Okay. But when an object covers unequal distance in equal interval of time, then we say that type of motion is what? That type of motion is non-uniform motion. Okay, students? So what is speed? We can define speed as the rate of change of distance. Okay, rate of covering of distance. Sorry, students. So we can define speed as distance divided by time. So that will give us the speed. Speed is equal to what? It is equal to distance divided by time. Okay, students. So when an object is moving in a straight line, there are some characteristics happening to it, like it will be having an average speed. It might have an average speed, or it might be in a uniform or a non-uniform motion. Okay, students? Right. So what is the difference between the distance and the displacement? So distance is a scalar quantity, whereas displacement is a vector quantity. Okay, students? So distance, in when we are talking about distance, it is sum of the distance covered by an object in all the direction that it has moved. But when we are talking about displacement, it is not so. It is the sum of the vector components only, right? So distance can be positive only, it cannot be negative. Okay, but displacement can be either positive, it can be negative also, and it can be zero also, right? So how can we justify that point of reference is used to describe motion, students? So we know that to describe any motion, we need to use point of reference, because when we are not using any point of reference, then what is happening? Our context is not there. Like we took an example of persons sitting in a bus or a train. We might be sitting very close to each other, holding our hands together. But then again, a person who is sitting outside the bus, from his perspective, you are moving, but from your perspective, you are stationary, right? Your perspective inside the bus, you are stationary. Okay, students? So now let's move ahead with your question part. So in your homework, try to find out the difference between the magnitude of the distance of school to home. Okay, students? Right. So thank you, students, for attending this class. Have a nice